All right. Yeah, let's get this party started. All right. Thank you, everybody. This is Greg Hunt from Chicago Faucets. I really appreciate you taking out some time for this first part of a series of three webinars that we're doing. Um, we do have a couple little housekeeping things. We do have a Q&A section if you have any questions along the way. We'll also open up for questions toward the end. And with that, I'd like to introduce Brian Yelton to talk about this webinar, Plumbing Design Strategies to Minimize Waterborne Infections in the New Age of Water Management. Take it away, Brian.
All right. Thanks, Greg, and appreciate you guys bringing me in today to have a discussion about water management. It's a topic that comes up in our line of work pretty much every day anymore. A lot of confusion, a lot of uncertainty, a lot of people that don't know a whole lot about what we're looking at. There we go. Who am I, right? So that's why you guys are all here. My name is Brian Yelton. My company is Inland Sales Group. So we come from a different factor of water management. We're a manufacturer's rep company. So I've been doing this for a little over 30 years. Had a big interest in the Legionella well before it even became a subject to talk about with engineers, facilities, and everything else. So I've been around this Legionella world since its inception in the plumbing side anyway. And I hope to give you guys some insight today from our point of view, because we're the ones coming into the facilities, coming into the contractors, coming into the other places that we don't live. They're not our buildings, they're not our facilities, but we're helping people understand what they're up against. And that's what we're going to try to get accomplished today, is kind of give you the lay of the land of where we currently are. So as we look at today, here's our objectives. They're quite long. We could spend the next 10, 12, 14 hours today if we really wanted to go through all this, but we're not going to. We'll limit it to a little less than an hour, but we'll kind of go through, brief overview of the pathogens. We'll talk about the main causes. Where are we at today in the world of mechanical and plumbing? It's a little disheartening. We've got a long way to go. Talk just briefly what the difference between a code and a standard is. And I know in plumbing and in facility management, we use those words interchangeable. And I'd like to kind of get that clarified today. We'll talk about current codes and standards, review how do we reduce these pathogens. And then we'll talk a little bit about new products, new parameters, things that we're going to work on. So it's all encompassing today. It's a lot to look at in a short amount of time. Believe me, as I spent many hours trying to get this put together and very concise. But, as we get started here, look at, waterborne diseases affect 7 million people every year. It's 3 billion in our healthcare. And I know that's understated. But when you start looking at that number itself is massive. And we really need to look and design things differently than we've had in the past. For the first part of our 20th century, we talked about all these ones that you see on the screen currently. And those are just waterborne pathogens that were in our water systems, and our water purveyors knew about them and they took care of them and things like that. But, for the most part, we don't hear these conversations too much anymore today, because most of the time our water is taken care of from our water purveyor. But today we're realizing that there's a whole bunch of other stuff in the world, right? Our water can have a big effect on our day-to-day life, respiratory illness, skin problems, bloodstream issues, all kinds of things, right? We can break it in, we can drink it in. It can be on certain things within our healthcare facilities, such as things that grow outside the water, things that kind of scare you, right? And we talk to a lot of infectious people within the healthcare world. There's Legionella is on the list, but by far it's not the most highest one, because it still does have a finite amount of people that get ill. But at the end of the day, if we do things right for Legionella, we capture a lot of other things at the same time. And that's really what we want to try to look at, right? But these are the ones that are kind of popping up today in the world, right? And most contractors, most facilities outside of healthcare have no idea what Pseudomonas is, Burkholder, non-tuberculous mycobacteria, those kind of things that come and go in our water, and we don't even know it's there. So it's really something I wanted to just bring forward is that Legionella, yes, is very important. But when we get to one of the ASHRAE standards further along today, you'll see that it's more encompassing than just Legionella. But Legionella is kind of our banner flag that we carry every day because, for the most part, most everybody in America today knows what it is. They have no clue where it came from or what it does or anything like that. So we move on, right? So the most common, though, still in our world is Legionella. And I do probably, I don't know, 20, 30 different CU classes throughout a year, easily, if not more. And every time I start is, what do you know about Legionella? Raise your hands and tell me what you know. And it's kind of scary how few people actually know really what it is and where it comes from and how it affects us and how we get to a point where we can take care of it and things like that. But we'll kind of work through that today to give you some identity of what we're looking at. But there's the guy, right? There's the Legionella guy. There's 50 or so different types of bacteria, Legionella, but the one that we need to be really most cognizant of is the serogroup 1. And many of the people that have facilities or work in facilities do testing and all that. And a lot of testing facilities will tell you that Legionella is present, but they may not tell you exactly what serogroup it is. And that's somewhat very important. I was just at a facility less than a couple weeks ago, and they got their test back and it showed Legionella pneumophila present, but it didn't say which serogroup was. So luckily we pushed back and we got some more detail and it wasn't group 1. So not that we don't stop, but we have to move forward because number 1 is the one that causes almost all of our illnesses or sicknesses within our field of coverage. And this slide we've used for years. It just shows you the effect or the timing of how quickly these little guys actually grow. We start from 5 minutes over the left-hand side and get over to the right-hand corner, and it's up 14 hours, and we've infected a bunch of more cells. And I can't tell you, every time I go out to a facility and the guys will sit in the mechanical room and tell me, well, I only have it over here. Well, today you only have it over here, but if it's in their 4 walls of your building, you're going to eventually have it everywhere. And it's usually just not isolated to one little area. It does move around, and that's part of the situation in plumbing that we have to be concerned about. Hopefully you guys don't have to see this, but that's what it looks like in a petri dish. It takes 10 to 14 days to actually grow and culture that little guy to make him grow and give you that positive yes or no. So it's imperative that we know what it looks like, have a good testing company that also knows exactly we're going to do it properly, we're going to give you the right results, and we're also going to help you through these things. But here's a slide that really kind of gives you the background. And when I start this slide, I always go back to look at the dates, right? When you start thinking of 1976, okay, well, I was just a tiny kid at that point, and at that point we had 224 veterans became sick, 34 guys lost their lives, and the CDC in that January named it Legionnaire's disease. And I'm still convinced today that if we had not named it Legionnaire's disease, if we had came up with some COVID-esque type name, it probably wouldn't be a conversation we'd be talking about today. But everybody thinks, well, it's Legionnaire's disease, it's isolated to old people, it's guys that fought in the war, it's that whole theory behind it. But all they did was tag it to an event. And they still can't tell us today, nor do they know, did it come from the cooling tower? Did it come from the showers? Did it come from this? Nobody knows. But it came forward back in 1977. Yet here we are in 2025, and we're still having this discussion about What is Legionnaires' disease? How do we get it? And why do we have it in our buildings? What else in our world are we talking about that is this old? Think about our technology from 1976 to today. A lot's changed. But unfortunately, plumbing isn't rocket science. It's slow. Everything else within our building is fast moving. Technology has gone into the HVAC side, it's in the electrical side, it's everywhere. We're just now getting plumbing to a point where we're catching up, but we still have a long ways to go. And that's what we're going to kind of talk about later today, too, right? So when you look at LD, it's bacteria that naturally lives in an environment, lives outside in our rivers and streams. But oh, by the way, it really likes our big, large plumbing systems in a beautiful tepid system. So I took this is a picture from one of Janet Stout's, who's the leader of all Legionella technology in the world today. Everybody thinks it's everywhere, but it's in 12 to 70% of our buildings. But when you think about that, that's a big number. So when I talk to facilities or classes, I'm thinking, okay, 70% of our buildings. So if you think about a building downtown Chicago, line up 10 buildings in a row, and if 70% of them have it, that's 7 out of 10 down the block. That's a lot of buildings, right? So that's where we kind of think about, where do we get this? Where do we clean it up? Okay. But what are the sources that we deal with? Okay. And this is by no means a complete list, but it's a list that we reference on a pretty regular basis. And the top one up there is the hot tub. And I'll sit here today and say I don't get in hot tubs. That's the number one thing, that if you have a hot tub and you take care of it yourself, that's great. Keep doing it. Be very diligent about it, right? But when you go to a hotel or go somewhere else and you don't know how that hot tub is maintained, that is a very critical piece, because when you think about it, you're sitting in a hot tub with water right up to your neck area, and it's bubbling, and you got misting all going on at the same time, and you're breathing things in. And by the way, that's how we get the majority of the bacteria into our body, into our lungs, is by breathing it in. So that's why cooling tower hot tubs are kind of suspect, right? Cooling towers, one of the easiest thing to take care of, because it's really not potable water, right? You're just going to treat the water that goes in the cooling tower. So it can be easily done with chlorine, heavily chlorinate the product to take care of the issue. The one thing that we always talk about with cooling towers is the carry, the mist. So when you think about all the buildings downtown or anywhere in a big place where you've got a bunch of cooling towers, the misting of a cooling tower has been documented. They can travel up to 18 miles. So, when you think about that, that's quite a bit of a distance. And that's why it's very difficult to understand where this stuff all comes from, right? So go down the list here a little further, decorative fountains. Think about all the nursing homes and assisted livings that were built in the 60s and 70s. What's the first thing you do when you walk through the door? You see a decorative pool or a fountain. And those are like the worst places you can have them, because now you've got a captive residency there that might be ill or might have other issues. So we're getting those taken out now. In our facilities in Illinois now, it's pretty much become code to get them out of the nursing home facilities, which is great. Swimming pools, if they're properly maintained, really not that big of an issue, but they can be. Sprinkler systems are one of those that most people don't think of, but it's in poly pipe that's 18 inches underground, and we have smart irrigation systems today. So that means we've got these little rainhead misters that water the plants, and they're right next to the sidewalks. And if you've got a hot, humid, rainy summer, that sprinkler system never purges. So that water just sits idle for, it could be a month, it could be 2 months, long enough to build up and grow bacteria within the system. So things we have to think about. Water misters. This is what I tell everybody. My family knows that we don't go near them, right? So you think about all the ballparks, all the amusement centers, all those places that have the water misters when it's 108 degrees and everything feels great, right? Except you have no idea where that water mist came from. Did they treat the water? Do they have good water? They have no idea. It's not like they put a sign underneath the mister that says this water's been treated by X. So we have to make sure we're taking care of those. Shower systems goes right along with hospitality and healthcare and all those facilities. Dental has probably done the best job lately to correct their situation. So they're putting in nice water systems to take care of, because once again, you're captive in that chair and they're cleaning their teeth and you're doing all that. So it becomes an issue right there. You've got open wounds and you're breathing in the mist and all that. So that's why we talk about that as well. And then the piping systems within our regular buildings. And of course, cruise ships. You know, every year we hear about all these people that get sick when they go on a cruise ship, and they don't really tell you what it is. Typically it's some form of bacteria, but they're not going to tell you exactly what it is because they don't know exactly where it came from, but they're trying to treat the water. But that's why you're seeing this prevalency in cruise ships, and they're really trying to do a good job of taking care of their water systems, but they are no different than any other building. It just happens to be a floating building. So those are kind of some of the bigger sources that we talk about. But, you know, when we start looking at facilities, there's a lot of these different products within your facilities. So what promotes the growth of Legionella bacteria? A low level of disinfectant in the water supply. What does that mean, right? So, well, every day we get our water from a water purveyor, a city, a village, somewhere, and they treat the water and they send it out. And then, you know, once a year in the mail, you'll get it says, hey, here is our water. This is what it is. It's safe to drink, and here's all our levels. That's 1 out of 365 days. But it's never going to be exactly the same. Maybe they're pulling from a different well, or maybe they pull from a different lake, or do they pull from this? We don't know. They don't tell you. They just tell you, here's your water, you pay for it, off you go. The typical standard today is 3 to 5 days of either chlorine or chloramines from the time it leaves the facility to the time it gets to you. So if you're in a area that the water doesn't get turned over very frequently, your levels of disinfectants are much, much lower. So that's where some of this stuff comes through. In addition to, depends on the time of year. Right now we're in the end of winter. Well, bacteria doesn't grow very often in water that's in 30, 40, and 50 degrees, right? But when you get in the summertime, where all of a sudden now our ambient water coming out of the ground could be 70 degrees, or you take Texas or Phoenix, where all of a sudden it could be 80, 90 degrees. Now the bacteria becomes alive and well just in your cold water, which then also causes a spike in bacteria at that point. Okay. Stagnation in the waterway is pretty self-explanatory, but what does that really mean to you and I? That means we're not turning the water over in our buildings. And we'll talk about that more here shortly. We've got heavy biofilm in the piping, and I'll show you a picture of that as well. Biofilm grows within our piping systems daily. Within a brand new building being built today, you could go and commission that building right now. Within 3 weeks, you're going to have a biofilm built up on that copper tube, and you will have life in there in your biofilm. Sediment in the system, algae, all these things become food sources. They come from our water. But then really, when we start looking at what really promotes it, is the water temperature. 68 to 122 degrees. So we'll talk about water systems here in a little bit, heating, and why it's important that we need to change our mindset on how we did temperature control. But who's all at risk, right? And this comes right back to, well, it's Legionnaire's disease, right? It's the elderly. This is the hot list that CDC comes back with, right? people over 50, smoker, chronic lung disease, weakened immune system, you know the list, right? And everybody says, yes, we understand it, and we should be able to take care of it just knowing who is at risk. And that sounds great, except I share this story pretty much every time we do a discussion about this. This one happened right in our backyard in Illinois. The lady you see on the screen there was 32 years old, and this is right at the height of COVID. And when you think of COVID and Legionnaire's disease, when you start thinking about how your body reacts, it's very, very similar. So in many cases, I've done talks where you start, if you put all the symptoms of COVID and all the symptoms of Legionnaire's disease side by side, you don't know which is which, but you can test to get both. And that's where so many times the COVID test went from 0 to 60, and it was always the first test. The Legionnaire's test has been around forever. It's not a difficult test. It's just up against healthcare insurances to make sure we can actually give the test. But this young woman was a school teacher, went to the hospital on 6 different times in a time span, and 6 different occasions was given a COVID test, and every COVID test came back negative. And while on the 7th time, finally a different doctor saw her and said, we probably need to test her for Legionnaire's disease. And of course, she tested positive. Well, within a very short time after that, she passed away from Legionnaire's disease. So when I show this picture and talk about this picture, she's not your typical person that would pass away from Legionnaire's disease. So when I go back and say, here's the who's at risk, yes, that is the higher percentage, no doubt. But just as we talked with COVID, there are people that died from COVID that were healthy people. We just don't know how our body will effectively take care of it. If you've got a great immune system or you don't. So I just like to show that because this is an important story that needs to be spoken about. So we talked, looking at our little biofilm cartoon here, that little brown stuff on the bottom is great captive, what it looks like, and all the little Legionella bacteria kind of in there, living in there. And by the way, that little brown area, you could superchlorinate up to 50 parts per million in there, and they're just going to tuck in there and hide, and they're going to live. They're not going to die. And then you'll see the free floaters that kind of move around, and water hammer arresters become a big thing. So our pipes don't shake. Or every time you go in and remodel your healthcare facility and they cut out pipe and they shake the pipe, and when you shake the pipe, the biofilm moves inside and it moves downstream and goes somewhere else, right? So that's what it kind of looks like. And these are the pictures that we see every day. I tell contractors every day, you look inside here, that you've all seen these. Oh yeah, we see that all the time. Well, do you know what's in there? Well, nobody knows what's in there. Just a lot of bacteria, really. Is it Legionnaire's disease? Who knows? We don't know. But within there, I guarantee you there's bacteria. There's a ton of bacteria. So some great little detail here from one of the companies we work with, Water Control. It's, when you think about flowing water, right? 380 million bacteria per gallon of flowing water. 243 in 1 foot of 1-inch pipe. So yes, bacteria very, very small, but in a sense, that's what we have to deal with when we think of how many thousands of feet of pipe do we have within our buildings, how many bacteria. Now, don't get me wrong, we do need bacteria. Bacteria is good, right? That's what builds our immune systems, and we need some bacteria to be healthy and all that good stuff. But it's really just to kind of show you within a pipe segment, that's a lot of bacteria, right? So where are we at with all this in the building trades, all that stuff said? We're really nowhere better than we were back in the 70s and 80s. We're finally starting to change a little bit. But I can tell you today, we're still designing plumbing systems that we did back in the 1980s. And we need to change that. We put in water heaters and we put in a mixing valve and reverse recirculate all of our buildings at 110 degrees. Well, that's perfect growth area for Legionella. So we kind of have to think past that, right? But there's very few codes and standards for construction designed for pathogen control. We just think about we just need to make our building work. How do we get our plumbing in situations to make sure we get it where we need it to be? Yes, we need to do that, but we need to take a few steps further to understand really what we have. So these next two slides are somewhat important because we all get stuck in these worlds of codes and standards. And I always like to say we have to understand that there is a major difference between a code and a standard. A plumbing code is a code that regulates and it can be enforced by law. Here in the state of Illinois, we have our own plumbing code. It's enforced by inspectors. It can be enforced by law. You can be fined. You can do all things wrong and be in trouble with a code. So we take a code and say, okay, that's what a code is, right? But what's a standard? A standard can be pretty much just a recommendation. But think about ASSE, right? They certify all of our plumbing products. In the appendix of most code books, you'll see here's the list of all the standards that have been adopted by the code. But the standard by itself can't be enforced legally. But if it's adopted by the code, it can be. So that is the biggest point that we need to understand, is that the standard is nothing more than a regulation that says, if you do this, this will be a good thing. Or it's a design parameter that says this mixing valve will do X or this faucet will do Y. Those kind of things meet the standards, right? But until that standard gets adopted by a code, it's nothing more than purely a recommendation. So those two slides I just want to cover briefly before we go any deeper, okay? So what codes exist for Legionella? There's a big list there, pretty much one. And it really has to do with cooling towers. And when you think about New York City and how many cooling towers they are, it's mandated. It's a great code for New York. It's a great code for cooling towers. It's easy. You just have to treat the water. You treat it in different ways, but that's it, right? That's a code forced by law. Remember that, right? But where are all the other ones? Well, they really don't exist. Why? Because no two buildings are ever alike. And this is where, when everything comes together and people say they want to design a building, we're going to do this and we're going to mandate a code and we're going to do this and we're going to stop Legionella from being built and grown in our building. Well, you can do everything perfect and still have a problem. So what does that mean? Now you've got legal issues that can happen, right? So if you build a building and say you're going to do this and you put it into a code and you still have problems, well, guess what? Now that state or that code can be sued. And so there's a majority of reasons why we don't see these things, right? But there's no perfect system. And we'll explain that a little further today. But that's the most disheartening part about it too, is that it takes an invested team to really understand, how do we deal with this? Where do we go from here? Okay, so here's a list of many standards that do exist that touch on Legionella or waterborne pathogen. I go back to the year 2000 and we'll kind of touch on a few of these, right? But I'm not going to go through detail. We could spend an hour or two dissecting each one of these standards, okay? Well, I'll just give you some of the higher points in there, but the bottom line too is, look at those asterisks on the bottom, right? Look at that. None of these are going to tell you how to take care of your problem. Remember, none of these are going to help you take care of your problem. They are purely just suggestions because they can't tell you what to do. It takes an approach to understand how we're going to do this. It's going to take your team, and we'll get through that today as well, right? But I like to show this one that goes back to ASHRAE 12/2000, right? So that's the year 2000, talking 25 years ago. And we start looking at some of the print there, and we talked about decontamination and flushing and getting our temperatures up and recirculating at 124 degrees. I can tell you the majority of facilities in my state where I live are at 110 degrees. We knew what to do. And if you dive into the standard further, they even tell you how to treat the water. But we chose not to do anything. So we just let it go. But that's how it all started, kind of in 2000, right? But then in 2015, the holy grail of ASHRAE standards hit. It's the 188 2015. And this is when finally everybody kind of said, holy cow, guys, we got a problem, and this is how we're going to do it. But if you read the standard doesn't tell you how to do anything either, right? It just gives you some understanding of what to do, how to build this water management team, how do we treat our building, what do we do, what's in our building we need to be concerned about, all those type of things that we need to understand. It's great because it started the process. But I can tell you today, I go in multiple facilities and I said, do you have your water management plan based on 188? I do. Have you read it? No, it was given to me by the corporate office. Well, it's the same one that they use for 14 different nursing homes. Well, those 14 different nursing homes are completely different buildings. They have different equipment. They have different water supplies. All these things are different that really needs to be dialed in by your building, not just a balloon approach, right? So that's when we start looking at 2015, saying, well, at least we're starting this process. But the bottom line, when you read the 15, it's all about documentation. And that's what it is with everything. Document what you do, document what you've done, and document where you're going. So you always have an idea where things are at and we're moving forward in the right direction. Now in 23, 514 came out, right? And 514 is a good standard. It's a great standard for healthcare. It's a great standard for people to understand because it kind of stretched our boundaries outside just Legionella. It hit some other water hazards that we need to understand. So those are the things that we need to understand. Is it physical, chemical, microbial? All these things are encompassed into 514. Okay, so it's a good thing. It's kind of tightened it up. It's much more restringent than 188 is. It's tightened up our building, so it's smaller buildings. So things we need to understand. But 514 is another great standard that we're getting better as we're progressing with standards. But you'll kind of see as we progress here is we're building upon all these other standards. We had 188, now we have 514. And then we've got this other guy that just kind of popped out of the weeds called ST108, right? And this is where all of a sudden in healthcare, this becomes a big thing of how do we treat our water that cleans our equipment, that we take care of, and all these things. And 108 is now being talked about in pure water situations where you never thought about pure water in hospitals or pure water to feed this type of building or pure water to feed our steam boilers. Those things all need to be looked at now. So 108 is great. It brings us a little more tighter parameter, but it is a little more confusing too, because now they say, well, here, look at this. Now we have categories of water quality, utility, critical, and steam, right? Well, utility versus critical. A lot of times, do you have different piping systems within the building? Not too often, right? So sometimes that critical water is in an area where maybe you just need to put smaller controls for an area per se that does the cleaning of equipment, all these things. So this all becomes part of your water management team we'll talk about shortly as well. And then we'll also talk about purity levels and treatment and monitoring and all the regulation compliance that deals with 514. But it's something that, or 108. So it's something we just need to be aware of. It does exist. It's going to be more stringent as we go. I threw this one in here just because I always like to put the EPA in there because, they're the ground zero typically of confusion in our world sometimes, because when you look at water sense or leads and all this stuff, they have standards that kind of contradict each other, but they've got a regulatory thing on Legionella. It says 0 organisms for drinking water. So basically, you can't have any. But when you read the bottom line, it says it allows for a margin of safety and non-enforceable public health goals. So once again, it's a standard that has 0 teeth, has 0 ability to say, if you don't do this, something will happen, right? But this comes directly from the government side. So it's what I like to say is that it does exist. This has been around for a while. It's not anything new, but we've just kind of really not been too concerned about all this in print. Okay. And then this energy code kind of came out in 21, and it's been adopted and put in a lot of places here. And when we think about international energy conservation, okay, you think about electricity, you think about all those other things, and but there's a couple really key plumbing items that we need to be aware of. Okay, that one is the hot water piping needs to be brought within 2 feet of an outlet of a public laboratory. The majority of buildings built today are nowhere near 2 feet. We're 10 feet, 15, 50, 60, 70 feet away. So they want to have hot water at the tap within seconds. That's their goal, right? So there are some states that have actually said, well, we want to take it further in their public than just the laboratories. We want to do all of our product in a facility. So sinks and other faucets and anything with warm water, we want to be within 2 feet. So it becomes an issue. Okay. So we are changing things. We'll talk about a product that can help that, but we have to understand that we want to have hot water to the stop quickly. The other concern that we always have here is that they want to have our pumps, recirculation pumps, turn off at night when no one's in the building. Well, water needs to move. And if we don't move, that's when things happen in our water. That's when things grow. So most healthcare facilities are concerned about their water. And the risk reward is run the pump. Because our pumps today are pretty energy efficient, very energy efficient. They adjust to demands and flows and they move back and forth. Leave them running, make sure we're moving our water and make sure we're recirculating. So we are in a point of conflict here with the IECC, but we like to always say, which one's going to rule first? Taking care of your water is always going to be first because you're not going to kill people with an energy code, but you can have an issue if we don't keep our water moving. Real briefly on the VA has a big, strong directive called 1061. Very strong, well written, but think about it. They've got a very captive audience in their facilities. They are elderly, they're people that are sick, all these things, right? But the directive from 1061 comes from Washington, and it's very, very similar to what the print was back in 12-2000 with ASHRAE, where we talk about thermal eradication. We talk about temperature monitoring. The VA wants 6 points of temperature monitoring throughout the building. So they want hot and cold water coming into your heaters monitored. They want the return line temperature back in the mechanical room monitored. They want the outlet temperature monitored. They want 2 points somewhere out in the other part of the buildings to be monitored as well. So that means we know what our building's doing at any given time. The VA would like to use temperature and flow before doing any additional treatments. That is the mandate on 1061. So this is a huge multi-page document. I just took a few things out of 1061, but I really just like to say it does exist. It's what we do. If you're not familiar with, go to CDC. They've got a great Legionella toolkit for you to work with. A lot of details within there. So use that as a facility, right? So water managements are our key. We defined them in ASHRAE and CDC. The hardest part of any water management team is you have to do an as-built drawing for your building. You need to know where every pipe goes. Who's going to do it? You guys. Nobody can come in and do it from the outside unless it's a contractor you're going to hire to do. But Everybody needs to be involved in all of this. Get it done. Okay. Who's on the water management team? All these people. They should be, at least. Building owner, maintenance people, safety officers, plumbers, industrial hygienists. All these people should be on your team. Who's on your team today? My guess is your team's not big enough. The team needs to be bigger. The team needs outside influences. Okay. So we push that in our world today. So, basis of a water management plan. This is all kind of decided and figured out in the CDC and all these things, but you create the team, describe your building. What do we have? Create the flow diagram. Where does things go? Where do we think we have possible issues or concerns? Like, what kind of equipment do we need to worry about? Do we have a spa or a healthcare facility that we have people that are captive and are sick and we can't leave? We need to worry about those people. Yes, right? We're going to identify all those issues. We're going to look at what are our control measures that we're currently using? Do we chlorinate the water? Do we run our faucets different? Do we do all these things? What are they? And then we're going to look at, okay, what are our corrective actions when needed? So if I had a problem, what am I going to do? Not look at each other and say, well, now what, right? So we have to have those plans. And we have to have contingency plans that say, what happens when my first plan didn't work? Where do I go from here, right? So some of that needs to be described out as well. And then ask yourself, does my plan currently work? And that requires you to look at yourself each and every day and say, okay, what have we done or what are we doing? And as many times as I get in facilities, just like I was in one yesterday, hey, are you doing this? Are you doing that? Oh, yeah, I do this. And you get two different answers all within 10 minutes. So what got documented? Did it get documented? They all say it gets documented, but those things need to be done. And then, do I need to adjust or change anything? If it's working, great. Put it down that it works. But if not, we need to adjust and change, notice, make changes, right? These are two things I've taken from the CDC. They're great, right? 9 out of 10 outbreaks could have been eliminated with a more effective water management plan. And the reason why the water management circle exists is when we go back to this, do I need to adjust and change anything? It goes in a circular motion. So you constantly move it around. And that form a team, people can come on and off your team all the time. If they leave or they knew somebody that came into the facility that has got a better background of information, use them. Bring them into the knowledge group to make sure that we're doing everything we can to make it work. Okay. I'll go through these real quickly because it's important for you guys to understand that there are some ASSE certifications for people that tie into building management teams. And every time I do a class or a CEU, I'll talk and say, hey, do I have any ASSE 12,000 people certified in the room? And it's crickets, right? These standards for certifications exist for people within your own companies, people within a trade, people like me that are 1280 will go through them. But at the end of the day, I've been doing this for close to 15 years plus, right? Before ASSE created all these certifications, I would get asked to go in somewhere and they would say, well, what makes you so smart? Because there wasn't anybody to certify what our knowledge base was or what we did. So this is really what is important, right? So all this is on the ASSE website, empowered to use it. But, we've got 1210 that's for construction and maintenance personnel. 20, which is going to be for infection control certification for employers. So you start thinking about, am I in healthcare? Am I in critical care? What should I understand? You're right. 1260 is water quality programs. Do you have a water quality program within your building? Is it important? Are you looking at how you treat your water? Do you add things to your water? These are the things where you want to have people certified within the 1260. And then you've got the plumbers, pipe fitters, and sprinkler fitters, right? And I will always say I would love to have more 1261s in my world, but I can tell you right now I don't have any, right? So I finally have one contractor, City of Chicago, that's working with me, is going to go through the process and get everything documented because healthcare facilities are asking. I use this contractor. He might be a great contractor, but does he have the knowledge or the background on this bacteria, the Legionella? Does he have resources that they can bring to you to be on your water management team? Those are the things we're looking for each and every day. So we kind of dialed it in with ASSC, with plumbers, pipe fitters, and sprinkler fitters. And then there's guys like myself. This could be for anybody. This is the 1280. This is by far one of the most interactive ones, the hardest one. It's the most long course. It's 24 hours, 3 8-hour days, but it'll give you all the detail and understanding of what 1280 is. It gives you understanding of the bacteria world and all those things that we need to be concerned with. And Janet Stout, the Legionella guru of our country, was the driving force behind all of this with ASSE 1280. So references, they're great certifications for your people or understanding to add to it, right? So what are the biggest contributors for bacteria growth? Lack of water turnover, low water temperatures. We got to move water. We can't just keep them sitting idle, okay? We have distribution pipe sizes that are way too big. You know, the state of Illinois, our piping was designed back in the 70s and early parts of the 80s, right? Well, guess what? What did we flush toilets with back then? 3.5 or 5 gallons of flush. What were our faucets? Way over 2.5 gallons per minute. Where are we at today? You know, 1.28 water closet. We're at a 0.5 GPM outlet on a faucet, maybe 0.35, depending on where you're in the country. All these things, but we didn't change our distribution sizing. So we're way too big. So what happens is we create our own problem within our own building. We don't get water turnover. So that means we're using low flow fixtures. We're not moving our water. And remember, 3 to 5 days from the water purveyor. And think about what happened in COVID, right? We got in our schools and our hospitals, and our hospitals were busy. We're everybody, taking care of those people, but our office buildings sat idle. So who took care of the water in the office building? Pretty much nobody. So we all went back to work, turned on the faucet, and didn't think much of it. You could have water that had been sitting there for weeks, maybe months, depending on how your building was set up. So water is aging out within our buildings, and it still is today. So we need to be concerned over, right? So these are the things we had. Chlorine levels are low water turnover, right? And our hot water systems aren't working at the regulations or what we should be to make sure we're capable of building enough hot water and recirculating hot water. That is the key thing, is we need to get our temperatures up and then also provide protection for scalding. This is a document as our company kind of put together. We used it for a lot of different things. This is the most recent one we just used for the Plumbing Contractors Association for Chicago. This is saying, hey, this is our guidelines for a school district, an office building. What do I need to do when I need to restart my building, or it's sat idle for X amount of time, or I shut down for Christmas for 2 weeks, my plant's shut down. When I come back, what should I do, right? These things all need to be looked at. So it's just kind of a nice handout that we use. Help is on the way. Dan Cohn from IATMO is working on this. He just finished the residential demand calculator. As he puts it, they're not trying to get smaller pipe size, and they're just trying to get the right pipe size. It took them 10 years to get the residential side. I asked him when we're going to get the commercial side. He just rolled his eyes. He's working on it, but it will come. Help is on the way. Water flow is a key element. We want to make sure we are doing what we can to flow the water through in our systems, day in and day out, right? Sensor faucets are an easy way to do this, right? We can adjust our faucets. We can make them run longer. We can eliminate stagnation, help in recirculation. Just like yesterday, I'm on a facility that said, well, our recirculation doesn't really work well. Well, guess what? We can put a sensor faucet to kick on and off by itself and it'll pull that warm water down on a regular basis to an area that may not have it before. So those kind of things really help, right? We're going to increase our hot water temperatures throughout the building, right? So we're going to make sure we're doing all these types of things, okay? But when we look at designing a hot water system, this is the gold standard that we're really trying to achieve today. And that means we're looking at hot water temperature at 160 at our source, master mixer at 140. We're going to recirculate that water at 140 degrees throughout the entire building, use point of use valves when needed at 110. We're going to use thermostatic and pressure vents, shower valves, set them at 110 or below, whatever you want them to be. And we're going to minimize all of our dead legs. And then we're going to recirculate as close as we can on all of our hot water fixtures within 2 feet. If we do that, we will help our buildings in an immense way. We will minimize the amount of bacteria that we will see. Look to digital TMVs to help you. They can do so much more. Digitals monitor temperature 24 hours a day. Legacy mixing valves, bimetal, wax, whatever type you want, only really temper water when new water is introduced. That means the faucets turn on. A digital tempers water 24 hours a day, no matter what. So think of that. Make sure your ASSC 1070 devices can be purged. That means we can go up and put 160, 170, even 180 through them if we're monitoring them to clean them. A standard ASSC 1070 device cannot do that. It's going to tap out at 120. So make sure you look at products like this, the Chicago faucet at 131 FM, a great key, okay? We need to change, look at our hospitality, hotels and resorts. We need to do the same thing, go pressure balance. We need to maybe put 1070 valves in the room or do each room under its own thermostatic control. A lot of things need to change, right? Some healthcare or hospitality chains are changing this. Hilton is very proactive in this. Marriott is starting to do more. We need to understand that the transient of people going and coming, this is an important factor we need to be concerned about. Looking at our hot water systems. This is from Special Pathogens Lab, Janet Stout's lab. Of 27 outbreaks, here's the percentages, right? 44% were hotel and resorts, right there, almost half. And the rest of them are all kind of pulled down below, right? Senior care communities, probably the ones that have the weakest water management programs of all. And they also have the most captive residents that have healthcare issues. So when we start looking at all this, yes, it's important. Long-term care facilities, senior cares, hospitals. Add those together, yes, it's more than the other half. But we need to be concerned about hotel and resorts as well. But when we think about nursing homes, patient loading is addressed, right? If you're not full, don't put them at the end of the run. Get them closer to the mechanical room. Maybe use some purging facilities, higher recirc temperatures. Make sure you have temperatures where you need to be and using thermostatic controls at the point of use or at the shower. You know, the state of Illinois requires Legionella testing for every nursing home, but they don't tell you what to do with it. They just say you must test. Once again, we have this code by the law that says you test, but it doesn't help anybody. You then have to go back to your water management team to get this moving forward. Prisons, county jails, other, things like this. When you think about it, people can't come and go in a prison. They're there. They've got elderly people in there just as many as they do younger people. So we need to look at their piping systems. They're doing water management systems in their systems as well. They're doing flushing. They're doing all these things to make sure that they don't have a problem. They've got bigger temperature control issues. Of all the ASSE standards for temperature control, they hit all 5. No other facilities typically hit all 5, but become what we have to do to make sure we take care of it, right? Schools, typically kids are great, very resilient, don't have that many things, except for look at the showers that never get used. Maybe look at removing those, right? Maybe we need to look at water control and say, hey, we need to flush more water maybe before the school starts or after vacations or all things. Go back to what we should do to make sure we've got clean water, right? kind of product development to kind of bring this all to an end. We're dealing with old infrastructure, old piping systems. We are way behind, but we can get caught up. It's not hard. It's just a matter of putting our minds to it and doing the right things. Change out, right? We can do chemical solutions to help if we want to. We can do injection type, which is, or non-injection type with filters and point of entry filters. We can change our temperature control. We can do all these kind of things to really help in our water treatment. We can look at system fixture solutions, right? Piping systems like a Kemper flow spreader, I'll show you in a second. Faucets we kind of talked about, but purge capabilities, rest of runtime, will adjust the run times, use the Bluetooth capabilities of a Chicago faucet, multiple flow options. In the future, we're going to tie these in with building management systems. Use the auto drain shower system where I'm draining my shower from my head down to my shower drain or shower valve so that stays dry and I don't have any bacteria growth. I may also use it on my hand shower so I don't have those issues, right? Here's a great example of a auto drain system where I've got a drainable hand shower. I've got a drainable diverter and a drainable valve. So now when those people in the hospital can't get out of bed, I don't have any water sitting in any of that sitting there right now. So I'm protecting myself without any problems. We talked about the sensors, right? But now we can actually add TMVs in there too that are purgeable. We can do things like that, numerous power sources. All these things kind of tie into let's put things in our building that help us do our water management job easy. And this is the kind of stuff that we can do. This is a little simple of a flow splitter, more detail out there for you guys, but basically this is the easiest way to get down hot water within 2 feet and it just recirculates back up. It's no different than a balancing valve, gets buried in the wall. It's meant for 50 years. Great simple product to get water moving through the building. We've got ultrafiltration that can pull all the bacteria out before it even gets into your building. We can do what we call a lens evaluation where we can actually pull the water and tell you what our chlorine is exactly today, not by testing it, just by having a sensor. All these things are on board that we can do to help us down the road. But when we look at the end of this, do your homework, ask the question, research products, use your water management team. Each building's going to be different. There's just no one single way you're going to do this. And there's no silver bullet solution. And the worst thing I tell people every day is you can spend a lot of money and still have issues because the water chemistry changes by the day and the month. It's up to you to be proactive and not reactive. Those are all my sources that I use today. And as Janet Stout says, our goal is 0 cases, not 0 Legionella. Legionella will exist. It's how we handle it and how we're going to take care of it going forward and in the future. And that's where we'll end today. Thanks for coming in today. We're at 57 minutes and we tiled in, and I'll turn it back to Greg.
Hey, thank you very much, Brian. Great information, as I suspected. And also, I know you crammed in a day's worth into a less than an hour presentation, so I appreciate that. Just a few questions, and then I know just in the interest of time, I'll let you go and get back to work. But got time for a couple questions. I'll throw them out there, and then we'll follow up with everybody. You know, this recording will be available, and we can also follow up with a little quick Q&A guide, just so everybody has kind of the questions and the answers that are provided. One real quick one, and this one's interesting to me as well. Is there a range for the definition of stagnation? Is it 0 feet per second? 0.001?
So really, it really comes down to there's really no standard for stagnation. Dead ends are coded for sure. Basically, it's 2 feet or more that sits idle is a dead end. But I always looked at when I talk about dead ends, they can be active dead ends too. So I look at Greg as you could have a water hydrant or a sill faucet on the back of a school, and you could have 100-foot run of pipe that goes back to that hydrant. How often does that hydrant get drained in the middle of December and January? It doesn't. So that is considered an active dead leg. So when we talk about stagnation in the water, it means basically we need to keep the water moving. And we didn't really cover it today, but we're not far away from having cold water recirculation and cold water chillers to make sure our water is moving on the cold water side. So it's a great question, but I look forward down the road, we will have recirculation of both hot and cold coming very shortly. This is going to keep stagnation at zero.
Awesome. Yeah, and there's been a whole bunch of comments flowing in. So we'll kind of sum all these up, get them out to everybody. And with that, Brian, I appreciate your time.
You bet.
Great
Thanks for
presentation.
having me, and hopefully we expanded our boundaries on Legionella today.
Absolutely. Thank you very much. And thank you everybody for joining. Have a great day.